All right, good evening, everyone. We'll get started in just a minute. And we're not going over the test today. I'm trying to figure out if anybody knows a way that you can see. I wrote on your submissions. So if there's any way that you can see that, or if someone was able to view it, please let me know. Oh, somebody said I can see it. Okay, if there's a way, something you do to see it, you just have to click on it. Oh, okay. So people are saying if you click on it, you should be able to see it. And I might have done something today that changed that because I changed one of the settings, but I'm not sure. So, okay. You viewed it today. Okay. So for those of you that haven't been able to see the comments I wrote, try to find it, take a look. If you have questions, you can come to office hours. Or I am after class tonight. Well, and it will be late because I have to run out after class, but I will post the notes from class as well as the test answers. So I will post that for you guys just so you can see. Sorry if it seemed tricky. I'm not trying to do that. I also am kind of told what test questions to put. But next time for the next test, I already kind of started. I asked for the test already, and I'm going to look through the questions, and I'll make sure that when we review, we do one that's like almost every test or almost every test question. Yes. For the test, I think. Well, I want to say the average is in like the 70s. I don't know. Is that not shared with you guys? I don't know. If it's not, maybe I can try to figure out a way, because I think there's like just an option that I can select so that you see the class average if you're interested. I could try to column statistics. I could try to do that right now. Yeah, so for this, the average was like a 70 and the median was a 77, which median was a little higher probably because there's few like lower and higher, but that's including the zeros. Like there were a few zeros. So I probably, for that average, I would probably not want to include the zeros. So it actually probably is closer to the median because of the zeros. But yeah, but thanks. Yeah, David. Okay. So we're starting on a new section today. Oh, and let me attempt to make my screen so I can see people, see the chat, see everything. Okay. All right, great. So today we're just talking really about sine and cosine. So trig is still here, but another reason I'm not really taking time to go over the course, I was telling a few other students, is that although maybe some like the unit circle is going to come up again, but the actual material on the previous test is not going to be on the next test. Like every test that we take is just going to be the material that we cover in that like time period. Yes, I mean, all math, I guess, is related, but we're not actually using, I guess, what was there. So I was hoping that, well, we also kind of don't have time the way they try to jam all this information at us. And we only have 2 days a week for an hour and however long, right? Okay. So this first one, we're going to use some decimals here just to try to graph this nicely. So you can get out your calculator or have Desmos up on the side or something. And I have mine, but please correct me if I'm doing this too quickly or doing it wrong. But let's just, if we want to look just at the graph of sine x first, I know sine of 0 is 0, then sine of pi over 4. And we're just going to get these decimals. We want to see what this graph looks like. So sine of pi over 4, we know that it's root 2 over 2, but that's about, 0.7, I'd say. Like we're going to try to round, okay. Am I still with you? Yeah. Okay. My internet seems real weak right now. So let's just, yikes. Okay. So somebody scream if I'm not there or I don't know. But so we have 0.7, then pi over 2, our sine is 1. So that's really nice. Then 3 pi over 4, it's 0.7 again, because it's root 2 over 2 again. And if you think about you know, this end point here, that's where we start. That's like 0. And let's do something nice here. So this is my, this is my initial angle, and we're doing all the pi's over 4. So this is like pi over 4. And then, this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7, all the way to 8 pi over 4, right? And I'm just going to write all these out for us, and maybe we'll do sine first. But just taking a look at this, I mean, I know sine of 0 is 0. I know sine of pi over 4 is root 2 over 2, right? And we're going to get that, we got that decimal there. Sine of pi over 2 is 1. And we can also think of it as the y value, right? In this, if this is like the y-axis, the x-axis, right? Then we have sine of 3 pi over 4 is again root 2 over 2, because see, y is still positive. These values, they do not change, right? Then we come back to sine of pi, which is 0. Sine of 5 pi over 4, which is negative root 2 over 2. And then, well, okay, I'm skipping. Sine of 3 pi over 2 is negative 1. And sine of 7 pi over 4 equals negative root 2 over 2 again. So if we're filling this in up top here, we get negative 1. Oh, I'm sorry, 0. What am I saying? We get 0. 5 pi over 4 was negative root 2 over 2, so 0.7. Then this was negative 1, then negative root 2 over 2. And then back to 2 pi, it's still just 0, right? So looking at this, if we want to graph this nicely, right, we're just given this little piece. I'm going to plot all my zeros first. So like this is a 0, this is a 0, this is a 0, right? So I'm going to plot 0, 0, and then they labeled it nice for us. So we have all these pi in terms of pi 0, 2 pi 0, right? So here's all our zeros. Then we have our positive 0.7s and negative 0.7s, right? Or our 1 and our negative 1. Maybe we should start there. So then we have pi over 2 is 1. Negative pi over, or negative 1 is 3 pi over 2, so it's here. And this, just when we finish this, this will continue like in this direction and this direction. So I'll show you that. But first, we're going to just, oh, I wanted to, oops, this is my bad.
Recording in progress.
I should have probably started recording after when I started this, but okay. So now we have our 0.7 and our negative 0.7. So looking at pi over 4 first, I have 0.7. So pi over 4, it's, I mean, estimate like there maybe. And then 3 pi over 4, I got 0.7 as well. So just try to stay in the same area, I guess. Then 5 pi over 4, it's negative 0.7. And then 7 pi over 4, also negative 0.7. So, okay, somewhere like this, right? Now we can kind of see this nice curve that's forming, even though I'm like a horrible grapher. But if you kind of connect these, I mean, if you're really feeling dangerous, you can connect it all with, without dots. But for me, sometimes it helps to just write dotted line. But this is going to be our sine curve. And it would continue, over here and over here, and it would look exactly the same. It would keep going up, then come back down. Then it would keep going up and come back down. So this, we know that sine is periodic to 2 pi. So what that means is from here, from 0 to 2 pi, this repeats itself. We could pick this up, like cut and paste it if it was, in real life, and we could pick this up, put it 2 units over, 2 pi over, and drop it down again. So you'll see this part of the graph repeated over and over and over, right? And you can see that like this point here is an extreme high. It's one of the extremes, right? Whereas this one is an extreme low, right? And then if we think, and then we know the zeros, right? The zeros all happen at 0, pi, and pi over 2, which was there, here, right? Okay. So there's our sine. Now our cosine, oh, except what happened here? Oh, they did our cosine for us. Okay. So how not fun that is, but maybe it's nice. So cosine is basically the same thing. However, in reverse, right? If we're looking at pi over 4 angles, right? Because when you look at your unit circle, now if we look at cosine of 0, it's 1. And cosine of pi over 4 is also square root 2 over 2. Sine or cosine of pi over 2 is 0. So they flip-flop a little bit, because when it gets to, because then sometimes they're positive, sometimes they're negative. When one is 0, the other one is 1. So they flip-flop a little. And you can see here that the graph is looking like this. So you can see the cosine curve. I mean, obviously the computer did it much nicer than I did it before, but it looks like this. And this is one period. So it keeps going. If we, like, it would keep going like this, right? And maybe I made that look the same, maybe it doesn't. But the key here is going to be looking at the angle, which is the x value. Cosine starts at 0, 1, whereas sine started at 0, 0, right? So that's going to be the difference. If you're like, okay, they look kind of the same. I mean, one of them maybe is a little more zoomed in here. Yeah, the graph of cosine, they zoomed that in more for us, so they made it look different, but they're the same curve. They're just shifted. So so sine starts at 0, 0, and cosine starts at 0, 1, right? So those are the big differences. And again, we have the same extreme. The highest value is 1, the lowest value is -1, and we have these zeros that keep happening, right? We would keep having zeros at pi over 2, 3 pi over 2, 5 pi over 2. We would just keep going. Okay. Now, the graphs of sine and cosine, like I just said, they differ by a horizontal shift. So basically, you can take the graph of sine, shift it one way or the other by pi over 2, and you'll get the graph of cosine, or vice versa, right? So what I just said is that sine of x passes, whereas cosine passes through 0, 1, right? And maybe I should have written it as I said it. But they both, notice how they overlap, they intersect every so often, right? You can see that. So we would say they both pass through either like square root of 2. Okay. They both pass through square root of 2 over 2 plus or minus, right? Sometimes it's positive, like in this case, it's positive. In this case, it's negative when equal, right? And then you can see that if I took that blue, like if I took the blue graph of sine and I just shifted it slightly over, like if you took a string to it, which if we were in person, we'd maybe do something crazy like this, and you take a string to this, right? And you maybe had it like glued in this way or something, and you just shift it, you'd cover cosine if you just move it over. So that's kind of, I mean, that's fun. So sine and cosine are very similar, but obviously not exactly the same, right? Okay, so now we have our domain, range, and all even and odd. We already have talked about this, but this is kind of just a reminder, right? And we're now looking at the graph. So now we're looking at the actual coordinates of sine and cosine. So the domain is all real numbers for both of these. I mean, you could substitute any angle you want, any number, and that's it. But our range is going to be like, look at the y value. So look again, I mean, you can look at both of these graphs up above here, but our range is the y, and y is only going as far as, well, these values here, 1 and -1, right? Whereas x, which is here, is going infinitely in both directions, right? So my range is actually going to be just -1 to 1 for both of these, and it can equal 1 or -1, right? And then even or odd, well, we should already know this, hopefully you do, but sine is our odd function and cosine is our even function. And then our period for both of these, the period, that just means, like when, if you think of the graph, the period is the distance on the x-axis that you need to go to complete one full cycle, I guess we'll call it, of the curve, right? And so for both of these, it's oh geez, all right, I keep freezing, so hopefully you guys are good. If I go from 0 to 2 pi, then for sine and cosine, it looks a little different, right? Because they start at different places, but I get one full cycle of the curve. And so that's our period. All right, now we've got some scaling. So vertical scaling, we'll say, in this case, the x-intercepts stay the same. Okay, so let's take a look at what this means. So if we have 2/3 cosine x, this is not going to change the x-intercepts because it's not going to change the 0. Like if cosine is 0 at this point and you multiply by 2/3, it's still 0. Nothing's going on, right? But it's going to change those extreme values, so 1 and -1, right? So what's going to happen is the extremes are going to be at plus and minus 2/3 instead of plus and minus 1, right? So instead of plus and minus 1, right? And this is for y equals cosine x. If I was just had no 2/3 there. So I'm going to changes, right? I mean, okay, the point values in between are changing, but in terms of the curve, it's going to have the zeros, the extremes, and then just connect the curve. Because I'm never going to ask you, like, you'll sketch these graphs. You're not going to have to get other crazy decimals, or if you do, you have a calculator, you know? So, so we know that cosine starts from, and again, I'm getting this if you're like, wait, what? Cosine, it passes through 0, 1. So it starts at that extreme point at 0, 1. So y equals 2/3 cosine x starts at 0, 2/3, right? So if I hit 0, 2/3, there's my extreme. That's going to be the highest it goes. Then I know at pi over 2, it's 0. The zeros stay the same. 3 pi over 2, it's 0 again. So I'm just plotting my zeros. My zeros stay the same, and maybe I'll label them. 0, 0. This is the extreme. Now notice when you have the next extreme, which is going to be at the end for cosine. So if we look back at this cosine curve, we had like extreme, 0, extreme, 0, and then, okay, we ended here, extreme, right? But notice how the two, oh, actually, that the extreme was here, my bad. Extreme, that's where it ended. I was getting a little ahead of myself. But notice how the extremes that are equal, they're at the beginning and the end of the whole period. And then the lower extreme is in the middle. So look, so 2/3. So I know at 2 pi, I should also get 2/3, right? At 2 pi, because it's going to look exactly the same. There's my zeros, there's my extreme, But then my lower extreme is at pi. So this is going to be at negative 2/3, right? And now I can just connect, yikes, my curve and try to make it look, all right, that's okay, right? Maybe I should have curved it a little more, but it looks something like this, right? And now we'll do the same thing for sine. So this here, this -2, this is going to give us a vertical scale times 2 and a reflection. If you remember from your transformations, a reflection about the x-axis. So in like, I don't know if it's like algebra 2 or I don't know, way back when, in one of the math classes before this, you should have seen some like transformation stuff. And when you multiply something, a function, by a negative, it just reflects over the x-axis. That's what's going on. So this is a vertical scale by 2, but also a reflection in the x. So this is going to look a little bit funky, but I mean, same idea. So here again, our zeros, like let's look up at sine again. So our zeros were here, 0, 0, and 0. Okay, so my zeros are at 0, pi, and 2 pi. So literally that will not change. So watch, I can just go 0, pi, and 2 pi. Okay, so I've already got 3 points. Now I want to get my extremes somewhere in here. So, so the extremes are going to be at plus and minus 2, right? Instead of plus or minus 1. But it's reflected. So normally, and I'll graph this, but maybe don't write this down yet. Normally, our extremes would be here, and we connect. But now, because it's reflected, they're going to be opposite on the x-axis. So they're going to be here and here, okay? So, I mean, I will erase these, but that's how I figured this out. You can also plug these values in, right? You could say, oh, what's sine of pi over 2? Oh, it's 1. Multiply that by -2. There you go, right? And now I can see I have my little sine curve. All right, that one was pretty good, right? And I have, like, when I plotted, I had a 0, 0, 0, extreme, extreme. And you don't need to be writing these. I'm just showing you, like, I actually didn't even calculate anything here. I'm just basing it off of the main graph of sine of x. And what's nice about sine, even though it's an odd function, its graph is a little bit more even, right? Because it slopes up or down for a loop and then around. Whereas cosine, an even function, but it looks, it doesn't flip itself kind of on the x-axis. It's not like 2 little loops. It's really just one, right? For one period. Now, a term for this, so we're not looking at anything new here, but the magnitude of scaling is called amplitude. So looking at these previous problems, 2/3 cosine, -2 sine, the amplitude of these problems was 2/3 and -2, right? So now looking at this, I mean, we're not trying to trick you here. We're just terminology. My amplitude is -8. And again, my amplitude is 2/3, right? It's just this number. Oh, actually, I'm lying though. It's not the sine. It's not the sine. Sorry. So, okay, I would probably give you points if you said -8, but the amplitude is just the number. So I forgot to say, not the sine. Oh, I can't even spell sine, GN. Just the coefficient. Right? Well, the number, just number of coefficient, right?
That's a weird question.
Oh, absolutely. Yeah. Oh, go ahead, Michael. But Jakob said absolute value. Yeah, amplitude, think of it like distance, right? From 0 or something. And that's why it's the positive value. Yeah. Go ahead, Michael.
Yeah, that's true. No, it's just, so sine and cosine, they're limited by the amplitude. And I mean, but they don't have horizontal asymptotes. Like, you know what I mean? Like, that's not one of their attributes. Is that right? I mean, even though they have like these limits.
Yeah, so they are kind of weird, I guess, functions in that way, but and the limits are in terms of the y value though, right? Not the x value. So yeah, eventually, like, and when you're taking derivatives later or things like that, that's in calculus with trig functions. Yeah, you're looking at the limits, and it is a bit strange that they're limited from like -1 to 1, or from like they have some restriction on the y-axis, right? Is that what you're saying? Sorry.
Yeah, that's what I'm saying. But we don't like think of it in terms of asymptotes. We think of it in terms of this deviation from the center.
Yeah, true. And I think maybe we don't think of it as asymptotes because they're not polynomials, maybe. Or like, they're not like rational or functions or polynomials. Because when we have asymptotes, it's typically for like rational functions. And even though, I mean, okay, there's different ways you can write functions because of the way that we write them. Yeah, I think that because they're not rational functions, we don't think of it as asymptotes.
Gotcha.
Yeah, but they all kind of bound by these asymptotes.
That makes sense. Yes.
Oh, I
Cool.
cut out. I'm sorry.
No, it's okay. I understood what you were saying, but thank you for
Yeah.
entertaining that with me.
Yeah, of course. Okay. So now looking at horizontal, so that was vertical scaling. That was basically changing our extremes either to be stretched higher, or in this case, kind of creeped a little bit lower between the -1 and 1, right? Now we can look at horizontal scaling. So maybe I'll try to stick to some nice color. So now we'll look at horizontal scaling. And what happens here is we substitute, instead of sine of x, we have like sine of 5x or sine of 1/2 x or something like this. So the graph of y equals bx, we're calling this capital B some number. And the graph of y equals x has a horizontal shrink or stretch. And what that horizontal just means, I mean, this way. So it's either, so take the original sine function, right? Or, okay, so say that's the original sine. We're either stretching it out this way, I'm going to erase this in a sec, or we're shrinking it so it's like this, right? Something like that. Okay. For sine and cosine, the factor B will affect the period of the graph. So before, for a vertical stretch, the period stayed the same because my zeros were the same. In this case, because we're stretching and shrinking horizontally, my period might be way wider or much less, right? It's going to depend on this number. And they show you here a horizontal shrink. So this is kind of when the function becomes crushed, like when I was doing kind of this type of thing. Okay, that's very extreme, but that the shrink is going to be when the absolute value of B is greater than 1. So it seems a little bit weird because you're like, okay, a bigger number is going to shrink you, but think horizontally. Multiplying by a bigger number is going to make our sine function repeat more often, okay? And then a horizontal stretch is going to be when the absolute value of B is between 0 and 1. And we're always looking at that absolute value because the negative, like we said before, the negative does something different. The negative does something different. It is the reflection piece, not not anything else. Okay. But so notice how something like this, we have sine x and sine 2x. So for sine x, we know, well, if we mark the zeros here, right? So look at what happened. My zeros for sine x, or here, it's that like gray dotted line. So it's kind of hard to see, right? But it's this here. And I have 1, 2, 3 zeros from 0 to 2 pi. But when I have sine of 2x, I then get 1, 2, 3, 4, 5 zeros from 0 to 2 pi, because I'm my new period, is 2 pi really divided by 2. It's cut in half. It's doing the opposite. So what's happening with the period? Okay, so maybe let's say a large number here, like greater than 1, really. It compresses the graph. Oh, geez, graph. And it's by like 1 over the absolute value of b. It changes the period by that. And changes period. We'll have an equation. I think next there's an equation for it. Yeah, so to find the period, you would do like 2 pi divided by the absolute value of b, right? And I think we will write that equation out at some point, I believe. I think right now we're just kind of learning about it. So yeah, so for this one, if we want to, when assuming b is greater than 0, we'll do this, right? If we want to see for sine of negative bx is just going to be y equals negative sine bx. Because remember, so this is where even and odd come into play. So looking at our sine, our period changes by 1 over b, and then our the negative, if there's a negative there, it just makes every point the opposite sign. So it's negative sine bx, right? Whereas cosine does something a little bit different, right? So let's maybe look at this. So cosine, I see a 0 here, 0 here, 0 here. There's 3 zeros. Oh, but this is 0 to 4 pi. Because I'm looking at, oh wait, this is still sine of 1/2 x. Okay, sorry. So they're just showing you what happens if it's 1/2. So now 1/2, they basically changed from a period of 2 pi in the original to 2 pi over b, which was 2 pi over 1/2, which is 4 pi, right? So that's what's happening here, 2 pi over b. And now our whole graph, our whole period goes from 0 to 4 pi. But what I was saying about cosine, so now we're just talking about if there's a negative there, because cosine is even, this is actually the same thing. So the negative in cosine has no effect, right? Because it's an even function. So you can actually kind of ignore it, right? Somebody said to find the period, we'll use that, right? It's not only pi.
Isn't it just pi? 2 pi.
Is what pi? Which one? Well, this, okay, so for
divided by 1 divided by 2.
this is pi, this one, right? This one is 2 pi divided by 1/2. So that's actually times 2.
Mhm.
Do you see? So this here is actually 2 pi times 2 over 1, which that's how I get the 4 pi.
Okay.
Because I'm dividing by a fraction.
True.
Okay.
I'm sure you're right.
Or well, you're looking at this right here, right? The 1/2 here,
Mhm.
not the 2 here. We were switching. Do you see what I'm saying?
You're multiplying with 2.
I can't hear you. Sorry.
You mean you multiplied with 2?
Yeah, we multiplied by 2 instead. Yep.
Okay.
And remember below here, we get these because sine is odd, and we get this because cosine is even. So maybe it'll help if we look at some examples. Okay, so we're assuming just to make this easier on us, I guess, we're gonna assume our period is gonna go like our original period. Well, this is always true, I guess, but we'll
Question, I'm
say,
sorry.
oh
I'm
yeah,
sorry. On where it's where, so is the point of this even odd, mention
mhm.
that B must be greater than 0? Does that always have to be positive?
Uh,
And so you need to
no,
make it positive by applying
no,
the even
so no,
odd.
so they're saying assuming, in this case, assuming B was positive, and I said, what is y equals sine of negative bx? They're just showing you that if there's a negative number there, you could rewrite it as this.
Gotcha. Okay.
Yeah, they're just saying or if it's cosine, you could just rewrite it and ignore the negative, which is pretty nice. So that's
Okay.
what we're going to look at here.
So
Yeah.
we're going to use that, okay, to rewrite it.
Yes, yes. It's really just for rewriting so that then we can focus on just sine of something or cosine of something that's positive.
Gotcha. Okay.
Yeah. Okay. So like for this case, I mean, we can rewrite this as y equals 2 cosine of 4x, right? Because the positive and the negative don't matter. And then we can say what's going on here. Well, this 2 is going to so now we're combining what we learned, and sorry for scrolling if that's confusing, but now we're combining what we learned up here, vertical scaling, with the horizontal scaling, right? So this 2 is going to multiply everything. Well, this is going to be extremes by 2. So the extremes will be, well, related to the 2, but then this 4 inside, right? This is a shrink, a horizontal shrink, by 1/4, right? Because 1/b. So by 1/b equals 1/4. Okay. So what we're going to do to get the period, and we're trying to find the period. So the period equals 2 pi, then times, or okay, I guess they want us to use the 0 too, which is kind of weird. So they want us to say the period is 0 less than or equal to, we're going to use this to figure it out, which, okay, maybe this is easier for you. I just like the formula, but we're going to use this. So 0 less than or equal to 4x less than or equal to 2 pi, because our original period is 0 and 2 pi. And normally this is x, right? But now all we have to do to solve is divide everything by 4. And so our new period, I guess, period of, or well, okay, I won't write anything. So the new period is going to just be 0, that doesn't change, is less than or equal to x, which is less than or equal to 2 pi over 4, which is just pi over 2, right? So based on this, the period is pi over 2, the new period. Again, I just like to use the formula and say it's 2 pi divided by b, but I guess I don't know if your homework will be like this or not, so I want to do it the same way as the textbook.
When we talk about
using,
horizontal shifting, I think that helps. But anyway,
oh,
because
okay.
it gives you the starting point.
Yeah, exactly. Right. Yeah.
But anyway.
Yeah. So we want to graph the function over one full period and identify the amplitude. Okay. So now we have this function. We have a 2 in the front, and then our b is a -4. Okay. So what we want to do, we have, if we want to, I guess, write out what these things are, we have vertical scale by 2, right? That's this. And then the -4 is going to be, well, it's cosine, so it's same as 4, right? Oh, this is the same one as above, so I guess I don't really need to rewrite this. So, but I guess I will. So same as 4. And it's again the horizontal shrink by 1/4. And so now let's graph these. So we know that cosine starts normally at 0, 1, right? And so, and maybe I'll label, they didn't, for the first time, they didn't label this graph. So I'll end up labeling this for us. So we'll do 1, 2, maybe -1, -2. Okay. Yeah, we're X. Okay, so I'm going to label the X-axis as we go. And I will say that for these types of problems, the labels on the X-axis in particular, but really both, is required. So like if you were to just plot some points and sketch this and not write what anything is, on a test or quiz, we would take points off for something like that. And I think in your homework, they might make you even label the axes. So we know it starts at 0, 1, but in this case, it's going to start at 0, 2, right? Because it's scaled by 2. And now, I mean, what the best, at least for me, the best way that I do this is to try to figure out where are my zeros? Like where have my zeros gone, right? Because normally cosine, well, okay, maybe I don't want to write it to be confusing, but cosine is normally 0. If we look at our previous, where's our previous graph? Okay, cosine is normally 0 at, this was pi over 2 and 3 pi over 2, right? But if I plug in pi over 2 here, I now, pi over 2 is my period. It's going to be my end. So my end point should be, this should be pi over 2. Because my end point is going to be my period, right? So now I know that my 0 is going to have to be in between these, like exactly in between 0 and pi over 2, which I know that's pi over 4. Again, you could plug in like pi over 6, pi over 4. You could kind of plug in some of these things that we know cosine for and see what we get. But it's going to be easiest if we make this, well, did I make this even? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4 in, so 1, 2, 3, 4. So this is going to be pi over 4, right? Because that's halfway to pi over 2. And then I guess we went by 8s. So like this is pi over 8, 2 pi, or 1 pi over 8. Oh no, maybe we went by 16ths. Oh geez. So this is like 1 pi over 8, 2 pi over 8 is pi over 4, 3 pi over 8, and then pi over 2 is 4 pi over 8, right? So it looks like that's kind of our scale. You could have scaled it again differently. Oh yeah, someone said, is period pi over 2 means the graph is finished? Yeah. So the question, period pi over 2 means our graph is finished at that time. We always will start at 0. And then we figure out where, I mean, you could start at any point, but starting at 0 is much easier. And then we want to figure out where does our first period end? And in this case, it's pi over 2. So that's our last point. And now I know pi over 4. Well, I know -4 times pi over 4, right? This gives me just negative pi, or same thing as positive pi. And cosine of that is, cosine of that 0? Oh yeah, cosine 0. Whew, I was like, wait, I did this wrong. So this should be 0. Oh no, it shouldn't. It's -1, right? Wait, what's cosine? All right, let's do this. Well, maybe I should have actually written these out because that's what I did before. So cosine of negative pi, and if we have a 2 in front, cosine of negative pi is -1, right? So this would be -2. Yeah, I wasn't finding the 0. The 0 is not, the 0 is in between sign, but in between of this, it should be the other extreme, right? Because remember, our graph has to look, well, it has to look something like it's going to look something like that. Spoiler alert, right? But I just want to find a few points to be exact. So at pi over 4, it's actually going to be -2. So here's all my extremes. And actually, I know that my zeros will just be in between. You could check like pi over 8, because you get 4 times pi over 8 and cosine of this, and then times 2, right? And this is going to be cosine of pi over 2, right? And that's 0. There we go. There's our 0. This one should be 0 too. Because it would be 3 pi over 2 when I multiply that by 4. And now I can see this is going to work out, right? This is going to be my function. Okay, that's an okay curve. I'm still not good at drawing these curves.
You could also just simply, like, whatever your period is, just divide it by 4, right?
Yes, so you can divide everything by 4 is probably what I should have done. I wrote out all the points for whatever reason. But yeah, you can divide every previous point by 4 and just you'll be done, right? Yeah, excellent. Okay, so now we talk about transformations of both sine and cosine with everything involved. When we have a number in front, we have a number in front of the x, we have minus or plus or some number, right? So now, I mean, this is looking at y equals a times sine of bx minus c, and y equals a times cosine bx minus c. And it's saying bx minus c, we're saying that's between 0 and 2 pi. We're going to go with that as our standard period, right? So what this means is you'll plug in the bx minus c and calculate the new period, right? Because now that we have this minus c, we are not always going to start at 0 anymore. So now we're shifting, we're getting real crazy, right? We're not going to start at 0. So if you're just doing a vertical or horizontal stretch or shrink or something like that, you'll stay at 0 because you're not changing, you're not shifting it left and right. You're just stretching and shrinking in vertically and horizontally, right? So it's like you're taking that string, and maybe if you think of it as an elastic, like a rubber band or something. So you're just stretching it and pulling it, but that 0 point is staying the same. Now, in this case, we're saying bx minus c, right? So we're saying, okay, we stretch and pull the elastic, but we're also picking it up and moving it over. So we're also taking that 0, 0, and we're moving it around. So we'll look at this first example with sine. 3 sine of 2x minus pi over 4. So we focus on the 3, and then we focus on the 2x minus pi over 4, right? So first thing we're going to do is get the new period. So I'm going to use this equation here, and I'm going to say, okay, 0, because we want to find the period, and the phase shift is part of the period. So that's going to be, where do I start? Where do I end? That's our shift, right? So 0 is less than or equal to 2x minus pi over 4 is less than or equal to 2 pi. Okay, so first thing first, we add pi over 4 to every side. So now I get pi over 4. Look at my 0 already went away. Well, maybe I should keep this in bold. Now I get pi over 4 is less than or equal to 2x is less than or equal to, okay, here's where you got to either get your calculator or use little math. 2 pi plus pi over 4. Well, okay, we could leave it like this and then simplify it later, or I might have written it as 9 pi over 4 right away, but we can simplify it after, right? Because I still have to divide by 2. So now I have to divide every single thing by 2, divide by 2. Okay, and that's the same thing as multiplying by a half, but we'll take a look at this. So pi over 4 divided by 2 is just pi over 8. I'm spilling into this here. Then less than or equal to x, which is less than or equal to, I'll rewrite this nicer somewhere else, but you could divide each of these. So this is pi plus pi over 8. So maybe it's easier to simplify at the end, because now this is just 9 pi over 8. If I add like 1 pi plus like 8 over 8 pi plus 1 pi over 8. So I'm going to rewrite this up here as, so we have pi over 8 is less than or equal to x, which is less than or equal to 9 pi over 8. Okay, so actually, oh, I I see why we want to keep it separate. Okay, shoot. Okay, so if we are going to combine these, but I'm going to explain why I'm writing it separate for now. So if you did combine it, write it separate just one time here, and you can see there's some terminology. Okay, it's not like a huge deal, but it is part of the question. So we should answer it. So looking at this, and let me know maybe if you can't see this. Okay. But looking at this final inequality that we got here, pi, this represents our period. I know this is going to be weird, but this is our phase shift. So stay with me. If we keep these separate, the cool thing is our period and our phase shift are separate. But like me, I combined it all at once and had to separate again at the end, which is not smart. But so what this means is this point here, we start here, right? Start at pi over 8 instead of 0, and at 9 pi over 8 instead of 2 pi. Okay? So we start at pi over 8, we end at 9 pi over 8, but our period is pi, and our phase shift, because everything is shifting by pi over 8. So let's try to graph this, right? So we'll start to graph this, start at when x equals 0. Okay. Oh wait, not when x equals 0, x equals pi over 8. I'm sorry. Start at x equals pi over 8, but when we plug this in, it ends up being 0. That's why I thought that. So if you have 2 times pi over 8 is pi over 4, and that's why when we plug that back into here, we're going to end up. Remember, you have y equals 3 sine 2x minus pi over 4, right? So subs into this guy, right? And I get 0. So I know, and maybe I'll label these here: 0, pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, which is pi over 2, 2, or I don't know, 3 pi over 8. I'm basically pi over 4. I'm going by 1 pi over 8 on each scale here. So then this would be 5 pi, 6 pi, 7 pi, 8 pi over 8. So this would just be pi. And then 9 pi over 8. Right?
The starting point is also not our phase shift.
Sorry, say that again. The starting point is what?
Is not also phase shift.
The starting point is part of the yeah. So okay, so the starting point should be the phase shift as well. So if you did combine it, but the problem is if you did combine it, then you don't necessarily know the period, right? Okay. So it's just nice when we keep it separate, but yeah, it should always match. Yeah.
I remember C over B.
Yeah, yeah, something like that. Yes, exactly. So, and maybe later we'll do the equations. I don't know why we didn't start with them, but yeah, we might. I think we're going to look at the equations later. So now I know at pi over 8, I get that sign is 0. And so I'm going to get this point right here when I plug in that pi over 8, right? And then if I want to figure out, okay, when else do I get 0? Well, or maybe when do I get the maximum? I know that at the very end, my final point, I should get 0, right? Because 2 times 9 pi over 8 minus pi over 4 is, if you do, well, okay, again, you could just kind of shift everything, but for this one, I was plugging in points again. But we know that so okay, maybe I should use what we know. We know the vertical scaling, I can't spell it, scaling is by 3. So we know that our highest point and our lowest point is going to be 3 and -3. So maybe I'll do, I'll do 1, 2, 3, -1, -2, -3, right? And so we know that our highest and lowest points are going to be at 1 or at 3 and -3. And so you can take so I shifted from 0 to pi over 8, right? So normally my 1, the point where I get 1 is usually at pi over 4, right? That's where I would get 1, but we're going to shift it by 1/8 pi, and then we're going to scale it up to 3. So this point is going to end up here. Okay, so we're going to have a point there. Then same thing goes for my -3. Normally, my -3 happens, or my -1 happens when we have, what is it? 3 pi over 2, right? Which is also, or no, 3 pi over 4, which is 6 pi over 8. So 3 pi over 4 is, it should be here, I think, right? Or, oh, but it's at -1. And we want to scale it, shift it 1 to the right, and then shift it down 3. So then my point is going to be here. And now all I really need to know is there's one more 0 too. But I know that sine of 0 is 0, sine of pi is 0, and sine of 2 pi, right? But look, my 0 was shifted, my pi was shifted. Oh, and pi, it's going to be pi over 2 because we're multiplying by a factor of 2 as well. So that was my bad. So normally it would be at pi over 2, but that will be shifted as well, right? So my other 0 should be here, just past pi over 2. Which if you labeled these, it might be more helpful because that would be 5 pi over 8, I believe. And now we can connect and say, okay, this is my new curve with my new period and all the good stuff. Oops. Okay. And so now, well, we're going to do a version. You have 3 sine of the same thing, but then plus 2. It's going to literally be the exact same thing, but this here shifts up 2, shifts everything up 2, right? And we'll just do the exact same thing that we did before and everything up 2. So let me label that. So I have 0. I'll still have pi over 8, 2 pi over 8, 3 pi over 8. So maybe we'll label every other one. 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8. So that stays the same. The only thing that changes is my shifting. Everything goes up 2, right? So I started at pi over 8, 0, but I'm shifting it up 2. So take all of these points up here and just shift them up by 2. And that's all I'm going to do, right? And maybe I should not do it in black. So here, then it was 3 pi over 8, 3, but now that's going to be up here. Then it was 5 pi over 8, 0. It's going to be there. And then it was this guy. And it's going to be shifted up 2. So negative, what was that? 7 pi over 8, -1. Ooh, okay, maybe I'm writing over that, sorry. And then back up to 2. So here's my exact same graph, but I added just a number at the end. If it was -2, and now looking at this, so looking at this problem, I mean, this part is the same as above. then this part shifts us up 2, right? So our range, it says to find the range too, graph it and find the range. Well, our range, look at the y-axis, and maybe I should have labeled -1, -2. So before, if we just look at the previous problem, our range was -3 to 3, right? The highest point was at 3, the lowest point was at -3. But then everything shifted up 2. So now it's this point and this point. It's -1 to 5, right? And somebody said, how do you find the 3 pi over 8 point? Well, so for that, I knew that if you're looking at these by, like, this is 2 pi over 8, right? But this is also pi over 4. So I just knew that, oh, the audio is not good. Yeah, this is probably my internet, which makes me really angry because it's supposed to be really good internet. I don't know if I enabled the closed captioning. I don't know how to do that. I thought I did, but maybe I didn't. So I will do this for next class or make sure it's done, because I'm sorry about the audio for you. And if it's really bad, I recommend maybe leaving Zoom and coming back in. I'm not sure. But for this here, our range changes from -1 to 5. And all you're doing is adding or subtracting the amplitude, really, right? So what happened here, like the range here was -3 to 3. And then we, for -3, we added 2. Well, for both of these, right? We added 2. And I'm supposed to tell you too, I don't know how relevant this is, but you can see that sine and cosine, they're like, there's this line for sine here, and it's called an equilibrium line. I don't know if that's going to be in your homework or not. I know it won't be on tests or anything, but this equilibrium line, you can also calculate the range. It's equilibrium minus the amplitude, and then equilibrium plus the amplitude. So like 2, and the amplitude is here, 3. So 2 plus 3 and 2 minus 3. That's how we got those. Okay, so now to get this actual formula, this is what I think Jakob or somebody was mentioning before, right? So to get this formula, we're gonna find a nice formula for period and phase shift, okay? And so we're gonna see exactly what Jakob said, I think. So if I add C to all sides, add C, that's what I do first, right? Then I get C is less than or equal to BX is less than or equal to 2 pi plus C. And then I say, okay, now divide everything by B. And so this gets me C over B is less than or equal to X, which is less than or equal to 2 pi over B plus C. Oh, C over B, sorry.
And I think the B must be always.
This is if B is positive, or you change.
Yeah.
We're assuming that you're gonna change the like sine and cosine based on even and odd. Yeah, we'll assume that it's positive, or you would take absolute value for the period, right?
Yeah.
But yeah, so we're assuming it's positive for now. And maybe a phase shift. So just like Jakob said, you get it on both sides. What?
The phase shift always positive, right?
Yeah. So this will also be, I mean, we're probably always going to do it positively.
I mean, the starting point may be negative, but the
Yeah.
if you
So the phase,
calculate the phase shift,
right.
it's-
So again, yeah, you would take absolute value of that. If B was like negative or something, again, you would take absolute value. But I guess if we do an example like that, which I think we will next, we'll talk about it. Yeah, because we talk about it next in the summary. So our phase shift is C over B, and then our period is 2 pi over B. And again, here in this case, we're just assuming B and C are positive numbers here.
Pretty cool.
Yeah, it's nice, right? I guess it's a good, it's not a bad formula to remember, just starting with 0 and 2 pi on either side. Now, here's where in this summary, here's where we can get into like all the nitty gritty and remembering if you really want to memorize these formulas and all of that, then you can, right? But you have to know, so looking at, if you read this summary here for these graphs, right? They labeled these, they're saying B is positive, right? So if B was negative, I mean, I think what that means is we're never going to see B being negative, but then you would take into account, like you'd have to take absolute value, or you'd have to switch it for even and odd and, put the negative somewhere else or something like this, right? It gets a little trickier, but we'll focus on B being positive for now.
I mean, it looks like right there on number 8, there's an example where you have to apply the even
Yeah, exactly.
property.
Yep. And it is a little tricky the way that you have to do it. And we'll see that when I do the example, because it's not because of the minus C, like because of this part, you can't just say, oh, pull the negative out or keep it. It's the same. You have to kind of manipulate it, and we'll take a look. So amplitude is absolute value of A. So A can be negative here, right? So just notice maybe, so amplitude is absolute value of A. Our period is 2 pi over B. And remember, we're assuming B is positive. If it's negative, we would take the absolute value there, or we would get it to be positive. Phase shift is C over B. Again, B is our positive number here. And our vertical shift is D. So this is like, oh, it's up 5 units or it's down 5, something like that. Okay, so time is permitting. Lucky you guys. It says, except we still have one other kind of big or 2 big kind of problems to solve after this, but we should be good. So looking at this, for the function 1/2 cosine negative 2/3 x minus pi over 3. So our B is negative. So, like, what do we do here? So we want to rewrite this and try to, hear me out. I'm going to keep 1/2 the same. The amplitude's good. Okay, I'm back. Yeah. Then I have, so amplitude stays the same. I'm not changing anything. I'm just writing this so that it's in the form of cosine negative x, negative something. Because then if it's like, I want cosine negative clump of something, and I know this equals cosine that same clump. You know what I mean? Okay, so hopefully, and if it was sine, we would make it sine of negative clump is going to equal negative sine of clump. And let's see what that is. So I'm going to pull this negative out, but then I'm going to write in parentheses, here's my clump, right? If I take a negative out of 2/3, I just get 2/3 x. That's fine. But this changes to plus pi over 3 because I'm pulling a negative out of each of these things. So that was weird. I don't know.
So you're like factoring it out.
yes, I'm factoring, oh, my bad.
Factoring out a negative one.
Exactly. I'm factoring out a negative one. And it's weird. And most students, most anybody doesn't really like to do that. But then it makes it back to the basics of our formulas we know. And it's a lot easier to figure out. So we have this. So really what we're doing, I'll repeat kind of what Michael said. We're factor out the negative one, right? And it's from both B and C, right? If you're looking at like this up here or this up here, it's from B and C. Okay, so once we do that, now we can rewrite with a positive value B using the properties of even and odd. So cosine is even. Therefore, I'm going to write this exact same, I'm going to write this same equation here, but without the negative there, right? So let's take a look. So I'm going to say y equals 1/2, and I know cosine is even. So cosine 2/3 x plus pi over 3. And I just got rid of that. And now look at what we have. Now we have A is here, B is here, C is there. Cool. Now we've got it, right? But keep in mind, well, I guess we'll look. So we rewrote the function. We did part A. Part B is find the period and phase shift using the formulas that we have there, right? So we know that A is 1/2. I'm just going to rewrite these for us here. B is 2/3. Oh, geez. Okay. Hey, it's fine. Okay, hold on one sec. There's someone at the door. All right, go outside. Okay. All right. Sorry about that. Okay, so yeah, everybody turn your yeah, they are our watchdogs, right? Yeah, exactly. Miguel says, "Mom, pay attention to us." Yeah, they're pissed off at me. I'll tell them very soon, boy. You know, they're outside now. Hopefully, they stay out there for like an hour. Okay, so A is A is 1/2, B is 2/3, and C. Now this is the other tricky part because we took that negative out. C normally, remember how this is bx minus C. So technically this should be minus, but it's plus, which means the C was negative, right? So C is actually negative pi over 3. Not a big deal. It just, you know, you have to pay attention to that. That's, again, what makes this one a little tricky. Okay, so now I just do my whole thing with my 0 and my 2 pi. So I can do 0 is less than or equal to 2/3 x plus pi over 3. Well, actually, you don't even have to do this, right? Because you could just probably maybe figure it out. But we're gonna do this. So minus pi over 3, minus pi over 3 from each side. So then we get negative pi over 3 is less than or equal to 2/3 x, which is less than or equal to 2 pi minus pi over 3. Now I'm gonna, instead of dividing by 2/3, I'm gonna multiply everything by 3/2, right? Same difference, but so multiply by 3/2, multiply by 3/2, multiply by 3/2. Okay, so my final answers here, we'll bring them up here, will be negative pi over 2 is less than or equal to x, which is less than or equal to 3 pi minus pi over 2. Okay. And oh, actually, I just did all of that, but I'm kind of being dumb because they gave us all of these formulas. We could we could have just used this formula here for period, phase shift, and vertical shift if we wanted. And this really only wanted period and phase shift, so my bad. So we could have just said period. Oh, period. I can't spell. Period is going to equal 2 pi over b. So 2 pi divided by 2/3, which, and we could check ourselves here. We'll see. 2 pi, that's like times 3/2, which is 3 pi. That's exactly what we got here. So very good. We did our work correctly, right? My dogs are throwing me off. There's my reason. And my phase shift is c over b. So negative pi over 3 divided by 2/3, which is negative pi over 3 times 3/2, which is still negative pi over 2. And that's exactly what we got, here, right? So we did it right. So good work. These are our two answers for period and phase shift. And then if you really wanted to graph that, you could, but what's happening is it's taking that graph of cosine, it's shrinking it in ways, stretching it in ways, multiplying it in ways, and shifting it. So all of the transformations are happening here. And really my recommendation is you could graph this in Desmos and check it out. That's because we won't take time to graph that. We'll go to the next question. Oh, except I reordered these. Oh, that was smart. Okay, good. In my other notes, this problem was reversed and it didn't make any sense. So this is good. So now for this problem here, given cosine of x and then 2x minus 5, it says to find g, this little circle is composed with f. So g composed with f of x and its amplitude. Okay, then amplitude, period, domain, range. Okay. So to start, what this means, this is just g of f of x, if you didn't remember composition of functions, right? So this is just g of f. So g is 2x minus 5, or h of f. Yeah, sorry, I'm saying this right. Okay, so we're taking cosine, and maybe I'll color code a little bit here. So we want our f of x, which is this guy here, to be replaced inside, I guess, inside for this x right here. So I'm going to rewrite this. I'm going to say, maybe I'll just write here, g of f of x is going to equal 2 times, and I'm not liking this green. For some reason, I should just stick to blue. Equals 2 times cosine x minus 5, right? Because I replaced my f of x right here in place of the x in my function. Okay, you could also think of this as g of cosine of x. That's like another way to write it if that's helpful to you. But now we know from everything we kind of figured out here, 2 is my vertical scaling. So I'm multiplying everything by 2, but this minus 5 is my vertical shift, right? And it's going to be down because it's a minus, right? And then there's nothing going on inside here. This x is just x, so there's no negative. There's no b, like b and c are both 1 or 0. Like there's nothing going on, so that's nice. So what does it ask me to do? Okay, amplitude, period, domain, range. So looking at this, my amplitude, remember, so this will be my A. So my amplitude is just going to be 2, right? Then my period, okay, so this is where it's a little tricky. Bx minus c. In this case, our bx minus c equals just 1x minus 0, right? So b is 1, b equals 1, and c equals 0. So looking at this, my period, I have b equals 1. So my period's actually not changing, right? So my period is 2 pi. And then my, what else do I need? Domain and range. Well, okay, the phase shift, there's no phase shift because C was 0. So they're not asking for that. The vertical shift was 5 down. So we can find our domain and range this way. Well, we know domain is going to be all real numbers because there's no denominator here. There's no square root. There's no issue, right? It was, I didn't finish it. And our range is going to be shifting. So taking our cosine, which the range of cosine is normally -1 to 1, and then we're shifting everything down 5. So we can just subtract 5 from these. So our range should be,
And you have to account for the amplitude. Right?
Oh, right. I didn't account for the amplitude. Sorry. Okay, thank you. So really, if you think of that equilibrium that I told you before, the equilibrium is going to be at, it's going to be at 2 for this graph, right? Oh, sorry. Someone said, where did you get the bx minus 1? Oh, okay. So this right here, the bx minus c, sorry, somebody asked a question. The bx minus c, I got that from inside here. So it's just x. So that means my b had to be 1 and my c had to be 0. Hopefully that answers that question. Neat. And then we have, yeah, so I guess at our peak points here, we're going to have 2 minus 5. So instead of like -1 and 1 minus 5 and shifting down that way, we're going to multiply those by 2 first and then shift down, right? So starting at 2, like that equilibrium point, then we would do like -5 and 2 plus 5. I think that's how this is going to go. So the range should be, well, and okay, you can again correct me. I know Michael is looking at this here, which is good because I was very distracted. Is -3 to 7. Did I calculate that right?
I think so.
Yeah. Okay. I'm looking at it like I was going to look at the previous one, but I think that's what we did before. Okay, again, if you weren't sure for something like this, if this is on homework, graph it in Desmos, and that's perfectly fine. And you can see like what's the highest, or what I actually did was I plugged in points and I plugged in my extreme values, and then you're just getting that's your range right there. So the highest number you could get is 7 because cosine of x could be 1, and 2 times 1, -1. It could be -1. So it's really -7. Oh, maybe I flip-flop that. -7 to +3. Because you could get -1 and then you could get +1, which would be, yeah, I think they're flipped, right? Is that
-3 and -7?
negative? So, okay, so it should be this. So it should be -7 to -3 then. Yeah, that sounds better. Right, yeah, okay. So whatever, ignore this. Yeah, perfect.
There you go.
There we go. Yeah. Okay. And again, for here, I would just plug in points. You know that the maximum of cosine is 1 and -1, the max and the min. So plug those in, see what you get. There's your endpoints, right? There's your range. Okay. Now, I do want to know if we wanted, we won't take the time to do this one, but if we wanted to do f of g of x, this would be maybe a good exercise to do, right? F of g of x, which would be f of 2x minus 5. This would be a whole nother transformation because this would be cosine of 2x minus 5. And in this case, your b would be 2, your c would be 5, and your amplitude, your a would just be 1, right? And you'd have no vertical shift. So this one would be just a little bit different, right? So you could also kind of compute that. Check that out. Okay, so the last problem for today is this little model sinusoidal behavior. So it's just an application that that's using a sine function, really, or actually uses cosine, right? So the monthly high temperature in Buffalo, New York peaks at an average high of 80 in July, down to an average of 32 in January. Doesn't that sound horrible? That's why we're all in Texas, right? Assume that this pattern for the monthly high temperatures continues indefinitely, yikes, and behaves like a cosine wave. Okay. We want to write to model the average high temperature h of t for the month where January is t equals 0. So we're going from t equals 0 to t equals 12. So in this case, well, we want to know, t equals 0 to t equals 12, because that, I mean, if you kept going 13, it would repeat, right? One period should be 0 to 12. At least that's what we want. So they already graphed this for us. So this is like, this is what they're expecting, or this is what, based on this, we're going to write our function. Okay. So we want something like y equals a cosine bt minus c. And so this is why well, okay, they said x, but this is t. They're changing it on us to t. And so to figure out what these are, we need to figure out first, what is the amplitude, or what is the scaling, what's going on here, right? And so we can see here, we'll estimate, and I'm gonna estimate these points. So we'll estimate that this point right here is at 32. Okay, so our lowest, well, actually, we're not estimating, they told us it's 32. Then the highest point here is 80, right? And so in between 32 and 80, that's going to be our equilibrium. And this is how we can get our range and our shifting here. So we know that, how should we start? Let's see.
I think the amplitude is negative because this is a cosine and this is starting in the bottom.
Yeah, you're right. The amplitude is going to be negative. Very good, because you noticed it starts below and goes up instead of down like it normally does. But what I just wanted to write a few things that we know. So we know that the period is 12. I said that before, but I didn't write it. So we know that the period is 12, right? And we also know that the period equals 2 pi over b, right? But we also know it equals 12. So we can actually calculate b this way, right? So, and we'll get the amplitude next. We'll definitely get that as well. But so here, I would multiply both sides by b, or you could cross multiply and then divide. So you get 12b equals 2 pi. Then you divide by 12. So b equals, did I do this right? Yeah, 2 pi over 12, which is pi over 6. So b is going to be pi over 6 in this case. And our equilibrium point is just if we do 80 by 2 to figure out what's exactly in the middle. It should be that, I think it's 48. So it should be 48. So this distance here is 48. And so the equilibrium point, like somewhere in the middle here, means there's 24 and 24 on the y-axis, right? For this is looking at the vertical scaling. So our equilibrium is at 56. And the equilibrium is the shift. It's the vertical shift. So in this case, we are shifted up 56, and our D here is going to be 56. So this tells us that D is 56. So we found B, we found D. We need to now find if there's any A or C, right? But like Jakob
A
said,
is 24.
oh yeah,
I mean-
yeah, okay, and right, exactly. A is 24. This number is our A, right? But it's negative because of what Jakob said.
Well, A
That-
is the, I'm sorry, go ahead.
Sorry, my internet froze, or it looked like it froze. So,
Well, it's the absolute, A is always like the absolute value.
yes. Okay. Thank you. Good. So A is 24, but we know that because we start at a low point and are
A low
going
point.
up, yeah, we're going to have a negative value. So A is 24, but we know, or absolute value of A is 24, right? The amplitude. But we know based on how this looks, because it's cosine, normally cosine it starts at the 0 and goes down, but this is starting and going up. And so we know that A must be reflected in the x-axis. So, I'm just going to say by the graph, A is negative 24, right? So now if we want to write our final equation, and the last thing left is that,
B.
is C, but in this case, we started at 0. Like notice how we started just at this point 0. So we didn't shift, we didn't do any shifting in that way. So C, we actually did not shift. So here, no horizontal shifting. Because we started. And so to write our final answer, the way that they want us to write this, right? H of t is going to equal negative 24 cosine of, what was my b again? Pi over 6t, and then plus 56. Now, if you weren't sure how to get some of these, or you wanted to check, you can also plug in points. I mean, they give you, so you have this point here, 12, 32. Then you have 0, 32. Then you have 6, 80, right? So you could also substitute in these points. Like B, you calculated, and A, you can also calculate from this, from the graph. And then if you weren't really sure about the last point, D, you could plug in some points and try to figure out what that would be. Oh, and there's a homework tip at the bottom. Draw the graph first when modeling. So something like this, you'll always want, and it says part A, there's no part B. So this was the only part. From the book.
But you should be able to draw that graph just based on the description.
Well,
Yeah.
exactly. So yeah, so this graph is drawn in here, right? I don't think on your homework they're going to provide it. So so you want to just, if there's, well, I know there'll be homework questions like this, right? And so when you get them, look at, read the word problem and look at, okay, 80 degrees in July. So that's like, that's, July was month 6, right? Oh, technically it's, 0 is January. So, okay. So 12 is also January because we started at 0. So 6 is technically July. Okay. So that's a little tricky. And then 32 was in January, right? And that's at our 0, 0, 32. Then we had 12, 32 because we went all the way back to January, and then 680. So from those 3 points, I mean, sketching the curve doesn't really matter, but from those points, you can see if we're assuming, like the problem said, that it's a cosine wave, and it goes up and then down, that'll give you, yeah, you can get the period, the amplitude, you can figure out that just based on those points. Oh, sorry, question in here, not related to those. Is there a way for you to access our previous ALEKS assignments? Yeah, so I thought you could reopen old ALEKS assignments, but I guess if you can't,
you look at the report, you look at the score, you click on the score and it shows you the report.
Oh, but you can't do the problems again, is what you're saying? The scores in black. So you're saying you can't, which, is there any particular assignment, or all the assignments, Joseph, are like this? Any assignment? That's weird. Okay. I mean, I can take a look because maybe I changed a setting by accident or something. But I can make a note to take a look in ALEKS. And the only thing is, when you redo an assignment in ALEKS, yeah, thanks, David. In ALEKS, if you read, like, I can't leave assignments open because if you redo them, it'll actually change your score. Even if I don't, there's no option for me to say, it'll just say late submission. So then if you did your homework on time, but you go to do it again in ALEKS, it will tell me that it's late and it'll change your score. So I'm not sure how to fix that in ALEKS. This one appears in blue. So it normally appears and lets you just look at the problems, and you just can't submit anything, right?
Yeah, I had that same problem, like, because I was trying to do practice problems, like try to practice using the ALEKS before the test.
Right.
And I did one assignment and it made it like completely cleared my score, and I had already like finished it. I don't know if maybe like you do the due date and like score it and then leave it open and then we can do it. I don't know if that'll work, if it'll even let us go back in.
Maybe I'll make maybe I'll make like an extended due date the day of the exam, so that if you're studying for the whole unit, I'll try that. You can access your old stuff, but it will still count towards a 0, whether it says 100 or not. Yeah, see, okay, if you missed doing it. But if you did do it, I think, David, what he's saying is if you did do it, he wanted to look at the problems again. Oh, you can redo it if you did do it. I see. Yeah, I will. Well, I'll still look into those settings, but yeah, it looks like maybe in the group me, you guys can get a chat together, because it looks like a few people, like David saying, if you go to assignments, you can actually see it. Joseph, I know you did them. Yeah, you just want to see that. I get that you want to see them, what they were. Yeah.
And if you want to, can't you submit it like, as many times as you want? And
yeah, I just hope that, so I do need to check that the syncing in Canva, in Blackboard, I need to make sure, because my only worry is if you submit it and you got 100, but then you went back in and you only did one problem and you get a 10, if it changes your actual score in my grade book. You know what I mean?
Right. Yeah.
It shouldn't do that, you're saying?
Well, in my experience with ALEKS, like whatever your last score is, if no matter how many times you submit it, it'll keep that. But then if you like a higher score and then submit it, then that will be your score.
Oh, so
But it
highest.
doesn't write
That's
it
good.
over with
Okay.
a lower score.
Oh, then that's good to know because, but I will still look into this and, just into settings of Alex, but also I want to, well, now that we know, I think talk to each other in the group me about how to find your test comments or come to office hours and we can, but, because you should be able to view your test in Blackboard and look, I commented and just put like a check, or I showed where I subtracted points, right? So if you do have questions about that, I did show where that is. So just keep that in mind. And we can always meet in office hours. But yeah, so for today, we're done. What was that? 5.5. On Thursday, we'll cover 5.6. Let me stop sharing this. I saved those. You all saw that. So hopefully it does save. But I will post these notes tonight. And like I said before, I will also post, I'm also going to post the test solutions. I will post it under like completed notes and solutions or something like that. Just so you guys can see. And if you have questions, you can let me know. And again, for test 2, I think test 1 maybe is always the hardest. But I think for test 2, we will, I will try to do some really good review problems in class before that are almost the same, right, as what you're going to see. Okay. And then our question of the day today is going to be, what's your favorite month of the year? You don't have to say why, just what's your favorite month, right? Nice question. Okay, cool. So go ahead and answer that. And yeah, we're done for today. I know it's a few minutes early, but maybe that's nice for all of us. So have a great day. And yeah, I'll see you guys Thursday, hopefully with better internet connection.
Thank you. Yeah, hope your internet is a little.
Yeah, I don't know what's going on. We'll figure it out, but
You should do a speed test or something. I don't know.
yeah, we did one. Okay.
It's very fast.
I think because of
My husband and I
performance-
did it. The speed test said very good, and we're both having issues.
Probably because of the recording.
We can't. So Joseph said, I recommend Spectrum. We have Spectrum at our old house. We just moved this weekend, Joseph, to this, our second house. And Spectrum does not service this area. So we have AT&T.
Comcast or AT&T?
AT&T is the only option. And they claimed their service would be so much better when I called than Spectrum. And already we both are having issues working. So I'm like, okay.
Well, there you go.
Yeah, exactly. But we'll still try to, I don't know, see, maybe reboot or something.
Yeah. All right. Good luck. Thank you. Have a good night. See
Yeah,
you.
thank you guys. Thanks. Okay. All right. Yeah. Good night, Miguel. Yeah.